Welcome back again to my YouTube channel. Today we are going to look into JAM Past Question 2025 on physics subject. So we have a question on the board. The gravitational potential of 900 kilogram satellite orbiting the Earth at 20 kilometers from the surface is. We have the parameters given, the constant values. We have universal gravitational constant given, 6.67 exponential minus 11 Newton meter squared per kilogram squared. We have distance of the Earth given as 6.4 exponential 6 meter. Then we have the mass of the Earth given as 6 exponential 24 kilogram. So we have the options there. So to solve this, one thing should come to your mind is a question that was asked. So the question says, find the gravitational potential of 900 kilogram and not 1 kilogram. I want you to get the difference clearly. If you are asked to find gravitational potential of 1 kilogram, they are asking you to find gravitational potential. But if you are asked to find gravitational potential of any mass other than 1 kilogram, you are asked to find gravitational potential energy. And from this very question, we are asked to find the potential of 900 kilogram, which means we are to find gravitational potential energy. You know the difference between both. The gravitational potential at a point is the work done in moving a unit mass from that very point to infinity against gravitational force. But when you talk about gravitational potential energy, it is a work done in moving mass of a substance from that very point to infinity against gravitational force. So it is also applied in their formula. Let's see it on the board. Now we have gravitational potential and again we have gravitational potential energy. So we have these two formulas. The gravitational potential, we have universal gravitational constant times mass of the larger body, the body that gives out the what? That field. Then we have the distance of the body experiencing the gravitational force from the center of the Earth. So the R is the distance from the center of the Earth to the position where the body lies. Then the gravitational potential energy, we have universal gravitational constant, we have the mass of the larger body, we have the mass of the body experiencing that very force. Then we have the distance of that very body from the center of the Earth. Now, we are asked to find gravitational potential energy. That means we are using this very formula. So, to get that, we have to write down the parameters given. Now, we have capital G given in the question as 6.67 exponential minus 11 Newton meter squared per kilogram squared. Then we have the mass of the larger body, the mass of the Earth given. We have it as 6.0 exponential 24 kilogram. Then we have mass of the body experiencing that very force. We have it given, the mass of the Earth, we have it given as 900 kilogram. Then again, the distance of the body from the surface, R. Now, how are we to calculate this? If I have the Earth, then here it becomes the center of the Earth. And here is the surface of the Earth. Now, from the surface of the Earth, the distance of the body, if here is the body, is 20 kilometers, as was given there. You see the distance of the body, 20 kilometers. Then, the distance of the Earth from its center, which is here, we have it as RE. So when you add the distance of the Earth with that 20 kilometer, it will give you the value of R. So R now is the sum of distance of the Earth and the 20 kilometer. Remember to convert kilometer to meter. Now to get the R now, we have RE plus 20 kilometer. And the RE was given, we have RE here. So R now becomes 6.4 exponential 6 meter, is a meter, then plus 20 kilometer. And you know, kilo means 1,000. So 1,000 times 20 will give you 20,000. Then we now get the value of R. So we multiply this, we add it up to 20,000. So let's do that together. Okay, punch 6.4 exponential 6 plus 20,000. So we are going to have 642,0,0,0. So as you have the distance in this very way, you can also have it in a standard form. That is, you have 1, 2, 3, 4, 5, 6. So you put point here, 6.42 exponential 6 meter. Then you've got the distance. Hence, we now do the substitution in order to get gravitational potential energy. So we have gravitational potential energy from the formula. We have capital G now, given as 6.67 exponential minus 11. Then we have the mass of the larger body times 6.0 exponential 24. Then we have the mass of the smaller body, which is 900. We have 900. All divided by the distance of the body from the center of the Earth, which is R. So the value of R, we have it as 6.42 exponential 6. So if you simplify this, then let's use our calculator and the punch. We have 6.67 exponential minus 11 times 6.0 exponential 24 times 900. Then we have 3.6018 exponential 17 divided by 6.42. Okay, let's divide. 3.6018 exponential 17 divided by 6.2 exponential 6. Then we are going to have as our final answer 5.6 exponential 10. Then the unit becomes joule because we are talking about energy. So if this lesson was able to help someone out there, please don't forget to subscribe, share, and turn on notification as we are going to run a full package